Welcome back everyone to the Hello World Guide. This is another episode of the Raycasting series, and in this video we are going to look at some pathfinding for our monster. And by pathfinding I mean that the monster will be able to find its way to the player while avoiding the obstacles such as walls and stuff. So in order to do that, what we'll do is we'll begin by I have already created a new file which I have called pathfinder.h and pathfinder.cpp. So this will consist of a class which will contain most of our all of our pathfinding functionality. And what we will do here is that you can see that we have got a class pathfinder, and here we have got a using directories just to make stuff accessing easier. So we have basically got a pair of two ints, and we type def or use that as node. And the way it works is that we construct our pathfinder providing it a map, and the pathfinder will create a graph from that map. The graph will represent basically all of the nodes in the map and all of the children of that node in the map, and each node will basically represent a cell of the map that is free to navigate. And then what we will do is that from this graph that we have calculated, we will perform a simple breadth first search algorithm on this to find our path. So the way it will work is that we are going to have a map. As you can see, it's just a std map here of nodes to a vector of nodes, and this basically represents the actual node, and this represents all of the nodes that are kind of, you could say, the children of this node, which are navigatable. And similarly we have got a function for accessing this if you want to debug draw this or something, but the main function is this, which is the get path function. And as you can see, this takes a start position and a goal position as vector to ice, and then it constructs a vector of nodes, or a basically which represents our path, the nodes that we need to go through to reach the end. And this function will rely on this function which performs the actual breadth first search algorithm, and this returns a map of nodes to other nodes, and we'll understand how this works in a second. And let me go ahead and open up pathfinder.cpp. So for the construction of the graph, what we do in the beginning is that we define an array of directions, and this basically consists of 8 directions, basically representing both the left, right, top, bottom, and all of the diagonal directions as well that we can go in from a particular cell. And for constructing the graph, we loop over each cell of the map. For each cell we check if it is empty, and because only empty cells can be added to the graph, since only empty cells are walkable. And then we get a iterator. We find that empty cell here for that x and y value, and if it does not exist in the graph already, then we just create an empty one, and if it does exist in a graph already, then we create a vector of nodes which is not empty but is equal to whatever value was present already. And then we go ahead and basically go around like each of the direction in that way. So we take our node and check all of the nodes around it, basically top, left, right, and also bottom, and the diagonal nodes. We go through all of the directions, and if that value, so we add it to our current x and y, and if that is empty, then we go ahead and push that back onto our nodes array. Basically we push all of the empty nodes that these nodes lead to. So for example, if we've got our first node and it has like 8 cells around it, and all of the cells that are empty will be added to this nodes array, and then of course we just assign it into the graph map, and this will construct the graph that we can use to perform our breadth first search algorithm. So the way we'll do our main breadth first search algorithm is that we are going to define a map of visited nodes, and this basically represents the node that we have visited along with the parent of that node. Parent basically means the node that we come to this node from, and this will basically get the path in a reverse direction, which means that we will start from the goal and make our way back to the inside of the get path function. After we have got this map from the breadth first search, we'll start from the goal and go back to the start. So here you can see we are adding the start to this map of SD tiles, and of course it has no parent because the start is like the beginning of the path. So we are going to specify that as a null optional value, and then we create a queue of nodes that we are supposed to visit, you could say, and we just define that with the start one, and while it is not empty we continue, and what we do is we get the current node by getting the front value of the queue, and then we pop that value. And if our current node is equal to goal, which means we have reached reached our goal, that means that we should end the breadth first search algorithm now, and we just break. Otherwise we get all of the children of this node, which means all of the node that we can potentially visit from this node, from our graph that we constructed earlier. So it basically represents all of the nodes around the current node, but only those that are actually empty and walkable. And then what we do is for each of the node inside of those children, we check if that is not present. So this count basically represents returns the number of times this value appears here, and for a map it will return 0 if the value is present, if the value is not present, and 1 if the value is present. So we basically check if it is not present in our visited, which of course means that we do not want to push it into our queue if we have already visited it. So if for the nodes that we have not yet visited, what we do is we basically add that to the visited map and set the parent to the current node, and then we go ahead and push that back onto our queue as well. So push the next node onto our queue. The current node is of course the one that we just popped from the queue, and then we push the next node onto the queue, and we continue this until either our queue is empty or we have reached our goal. And this will basically return us this map of nodes that we have visited. And to construct a path, what we do is first of all, in our getPath function, we construct the nodes from the actual vector to I positions, which are just those are the vector to i's, while this is like a pair of ints, and then we construct that. And after doing that, we get our visited map from our breadth first search, and then we get our path, which is just a vector of nodes, and we begin it by specifying it with goal, and we'll work our way backwards. Then we get our next step of the node, and we set it to the start by default, and you can also set it to null opt, because we just want the first to be initially an invalid value. And if our visited exists in the if our visited has the goal value, so if the goal node is present in our visited map, then we set our step to the parent of that goal node, and if it is not present, then our step will be equal to start, and if our step is start, then we'll just exit from the algorithm, which means that goal is not present in the array, which means that we cannot have a path to that place where the player is. There is actually no path there. And then what we do is we check if our step has a value, and our step is not equal to start, because if it's equal to start, then we have basically reached the end. So if that's the case, we just push that value of the optional back onto our path vector that we have got, and then we take our step and we set it to the visited value. Basically we set it to the parent of the current value, so we get our visited array and we use that to get the parent of the current step, and we keep doing that until we reach the end, and in the end we just return our path. So the next thing we'll do is in our game.h we'll just define a pathfinder here, and in game.cpp when we are initializing everything, what we'll do is we'll also initialize our pathfinder and pass it our map. And another thing is that in our game state structure that we've got, we'll also have a reference to the pathfinder, because obviously we want to access the pathfinder and use it from all of our things, so we should put that in our state. And when we are using the state here to update everything in game, what we'll do is we'll basically pass the pathfinder there as well. Now inside of thing.cpp, essentially what we'll do is that if I go up here, what you can see is that what we'll do is that when we are having our monster, we won't set its direction like we were doing earlier, and what we'll actually do is that we will get our path by using pathfinder.getPath. We'll just use our current position, cast it to a vector to y, and the player position also cast it to a vector to y, and then we'll get the last value of the path, get the x and y, and the last value basically represents the where we are supposed to go after the starting value. So it represents basically the next value of the path, which is the only one that we actually care about. And then we get our next value for the actual floating point next value. We just add 0.5 to both the x and the y, and the reason we do that is because we want to go from the center of one node to the other node. We don't want to go from the top left corner. And then we get our direction, and we convert that direction to the angle, and in the end we just move in the whatever angle we are looking at. So we are going to go ahead and see how this works. I'm going to go ahead and run make here, and what you should be able to see is that our monster can now chase us around the map correctly and somewhat intelligently. So I'm going to keep this disabled right now, and I'm going to go ahead and go to like here, and what you should be able to see is that if I go to the 2D view and I turn on this value, you should be able to see is that the monster kind of finds his way to us, and he avoids the walls correctly. But the thing is, you can see that he sometimes slides against the wall, and the reason is that we are moving like in a straight line from the center of one part to the center of the other part, which is obviously not very ideal. We want to have some sort of steering behaviors or something here, and you can see that the collision is a bit messed up too. We'll see how we can fix that. But apart from that, we are going to have to do some bug fixes regarding this pathfinding, and we are also going to need to figure out some steering behavior to make the monster's movement look somewhat more natural. So anyways guys, we are going to be doing that in the next video. Make sure to like and subscribe as well, and share this video with other people, and I'll see you in the next one, and bye.